All right, so we're going to go back over this again. So what we're talking about is we're talking about isotopes today. So if we look based on the test that we took, this is a scribe notation where you use the whole name with the dash with the 1. What does that 1 represent? The AMU. Okay? This is the name. Please write this down in your notes. This is the name, and this is the AMU. Now, if we remember, the AMU consists of the center of the atom, which has what inside the nucleus? What's inside here? Protons and neutrons. I got you this time. You got it. Okay. So if we're talking about that, and the AMU tells us what's in the center, right? Now let's look at this one. This is abbreviated. Okay? Abbreviated notation. Now, based on that, what does the H stand for? Which is the symbol. See, over here we did the name, but over here we did the symbol. What's on the top?
Number of protons.
Is it the AMU or the atomic number?
That's the AMU, right?
AMU, correct. And this is the atomic number, right? Okay. Do you understand what's going on here? Then we had where we figured out protons, neutrons, and electrons, correct? So all that makes sense to you. So let's look at our paper that we have. So what I'd like you to do is I'd like you to turn it to the side. So you're going to take this paper, you're going to turn it like this. You're going to turn it to this side. All right? We're going to do one together. Is everybody ready? All right, so on here it says, what is an isotope? Based on the lab that you did today, what would you describe an isotope being? What would you write an isotope is? Well, we just got finished doing a binium isotope, right? Do they all look like beans?
Yes.
Yes, right? So we're talking about elements that look the same but have different number of neutrons. So let's write that down. Elements that look the same but has different neutrons. Everybody good so far? We're on this sheet. I folded it. I'm on this side, sir. The next one says, what does the number next to the isotope specify? What is it?
Number 1 was elements that look the same,
but a different neutrons. What does the number next to the isotope significant? So in other words, this number here, right, beside the name, what does that say it is? AMU. Okay? So write down AMU. How can you tell isotopes apart? Well, how can we find out about the neutrons? What is the neutrons plus the protons equal? Protons and neutrons equal what?
the atomic number.
AMU, atomic mass unit. Okay, so those back there, the biniums, do you agree based on what you did back there that they weigh different?
Yeah.
Which one was the lightest one? The black one. Which one was the heaviest one? Brown one. They're all beans, but they're different shapes, right? Different sizes. And does it make sense to you? The larger the size, the heavier they are, because they have more neutrons in them. Is everybody good so far? Okay. Let's look down here. So this says helium, right? it tells us that the helium has a mass number of 5. So if I'm going to do an isotope notation, how would I do helium with the atomic number of 5? What would I write beside my box there? Well, Miss Sloan, helium I know is number 2. Where does the number 2 go? Top or bottom? Bottom. It tells me the mass has 5. Where am I going to put that 5? On top. So right now I put 5,2He. I'm right here. Okay. Protons, neutrons, and electrons. Now before we do that, let's revisit 8-man again. Are you ready? I'm going to erase these since you know this. I'll leave those 2 up. So, APEMAN. What does H stand for?
Atomic number.
Yep, push through. Atomic number equals protons equals electrons. Remember, right? 8 positive equal. Okay. Man. Mass number. Subtract. Atomic number equals neutrons because it's an N. Okay. Now, what am I going to put down for protons and electrons?
Wait, no. 2.
2. 2 and 2. Neutrons. Come on, drum roll, please. 3. Do you get it?
Not particularly.
Got the video for you just in case. All right, let's look at the one underneath that NE. Ready? We're going to do one more just because I want to help you. Mass number is 22. Protons, neutrons, and electrons. Okay. Neon. What is the atomic number?
Atomic number.
10. Where does it go? Top or bottom?
Goes on bottom.
10. Mass number is 22. Where do I put that at? On the top. Okay? Protons and electrons, how many numbers do I got? 10 and 10. What do I have for neutrons? 12. 22 minus 10 is 12. It all comes back again to everything I've taught you so far. And guess what? It'll stay this way all year. Let's flip this over because God knows we got another side. Okay. Isotope. What's an isotope? We've already said it. What does the number mean? We already said it. What atomic tells the isotope apart? What number 3 we haven't done? What is it? How can you tell an isotope apart? Oh, we did do that too, didn't we? Cool. So let's just mark out 1 through 3 because we've already done that one. And let's go down to these. Are you ready? Coronium 58 and 63. Okay. What letters is coronium on the periodic table?
24.
Is it 24? Look on your periodic table to see if that's coronium. We're going to see. It's 24 or 58. We all decide that.
Yeah, 24.
24. Cool. So I'm going to put 24 in the box beside it. So this looks like my box. So my box is here. So I have coronium 58 and I have coronium 63. And then I have protons, neutrons, electrons, and then I have this top one. So I put 24 over here so it can remind me. Are you ready? Protons and electrons.
24.
Okay. 24, 24, 24, 24. Does everybody agree? Because I know that protons and neutrons equals the atomic number. I know an isotope has more neutrons than that. So then what am I going to do? Well, I'm going to take 58 and I'm going to minus 24. I got 34. So what you got? 34. Then I'm going to take 63 and I'm going to minus 24. 39. Do we understand how to do the front and the back? Okay? You got 4 minutes. See how far you can get.